Today we will be demonstrating the testing procedures for aggregates, which are essential components in concrete and road construction. We use sieves for size analysis, a balance for weight, containers for water absorption, and a crushing tool for strength tests, essential for evaluating aggregate quality in construction.
Obtain a representative field sample of aggregate. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. After drying, cool the sample to room temperature. Then record the dry weight. Ensure that the sample size meets specification requirements. Stack the sieves in order, with those having the largest openings on top. Transfer the sample to the sieve stack without loss of aggregate. Hand sieve the sample or use a mechanical shaker set to the calibrated time. After sieving, remove each sieve from the stack. Remove trapped aggregate from undersized openings. Empty each sieve and record the weight of material retained. During this process, check for overloaded sieves. Note that individual or cumulative weights may be recorded, and the method chosen will affect subsequent calculations. Use a soft paintbrush to clean finer sieves. This will prevent damage to the more delicate screens. Finally, record the weight of material in the pan. Calculate the percent retained and percent passing each sieve. Report the percent passing each sieve to the nearest 1% except the number 200 sieve. For this sieve, report to the nearest 0.1% for values less than 10 and to the nearest 1% for values greater than.
Aggregate crushing value test. Aggregate crushing value is a measure of the strength of the aggregate. The aggregate crushing value gives a relative measure of the resistance of an aggregate to crushing under a gradually applied compressive load. This value has the important role in choosing aggregates for the construction of roads and pavements. The apparatus required for this test are a 15 cm diameter open-ended steel cylinder with plunger and base plate, as per the dimensions confirming the Indian Standard Code IS 2386 Part 4 1963. A straight metal tamping rod of circular cross-section 16 mm in diameter and 45 to 60 cm long, rounded at one end. A weight balance. IS sieves of sizes 12.5 mm, 10 mm and 2.36 mm. A compression testing machine. And a measuring cylinder of size 11.5 cm in diameter and 18 cm in height. The sample used for testing should be of oven-dried aggregate passing a 12.5 mm sieve and retained on a 10 mm sieve. The quantity of aggregate is filled on the cylinder measure in 3 layers and tamped 25 times for each layer. Once filled, level of the surface. The weight of material with measuring cylinder is determined and let consider it as W1. Now, the cylinder of the test apparatus is placed on the base plate. And the aggregates are filled in layers with 25 blows on each layer. The surface is leveled, and the plunger is placed on the surface. Now, this setup is placed on a compression testing machine and the load is applied uniformly such that the total load reaches 40 tons in 10 minutes. Later, the entire setup is removed and sieved on a 2.36 mm sieve. The fraction passing through the sieve is weighted. Let us keep this as W2. Now, finally, weight empty cylindrical measure. Let us keep this as W. Now, The aggregate crushing value is obtained by the equation W2 divided by W1 minus W into 100. The crushing value must be as low as possible to obtain better strength roads and pavements. The lower crushing value aggregates would provide a longer service life and a more economical performance. If the aggregate crushing value is 30 or more,
Our test results help decide if aggregates are fit for construction. K. Checking size, strength, and water absorption. We ensure they meet standards for safe, strong, and long-lasting structures.